The U.S. Air Force and Northrop Grumman are integrating new composite hot trailing edge materials into the upper surface of the B-2 bomber to increase the stealth aircraft's service life, improve durability, enhance sustainment, and eliminate the need for field repairs, service and industry officials said. The new composite hot trailing edge, HTE, skin, to be added behind the exhaust nozzles on the surface of the bomber, is made up of a durable, high-temperature material more resistant to degradation from thermal and vibroacoustic stress, service developers stated. The polyamide material presently used for HTE degrades quickly in this operational environment, as the incessant exposure to heat and engine exhaust exceeds its capabilities. The material cracks and the resin disintegrates, an Air Force statement said. Therefore, recognizing the need for more resilient materials, the Air Force Research Lab engineered a new application based on AFR-PE4, service information states. AFR-PE4 is a high-temperature thermosetting polyamide resin with service capability up to 343 degrees Celsius, according to information from Maverick Molding. Maverick, a high-temperature polymer firm, says they commercialized AFR-PE4 after it was first developed by the Air Force. Engineers working on stealth technology designs often try to reduce the heat signature or infrared thermal sensor detectability of the aircraft. The more heat a bomber gives off in flight, the more enemy sensors and radar are likely to detect it. Therefore, it seems evident that a material less prone to degradation or disintegration at high temperatures might likely lessen the heat signature emitted from decay or erosion taking place on the aircraft. Improving sustainment for the B-2 is a priority for the Air Force because the service plans for the 1980s-era stealth bomber to fly alongside the emerging B-21 Raider well into the 2050s. After extensive testing and demonstrations going back several years, the Air Force and B-2 prime contractor Northrop Grumman are now moving forward with plans to produce the new composite HTE components. Northrop recently awarded a 5-year, $90 million deal to Orbital ATK to manufacture 17 HTE composite parts, a Northrop announcement said. Production will take place at Orbital ATK's Aerospace Structures Division facility in Dayton, Ohio, later this year. The replacement showcases the coordinated efforts of personnel from AFRL, Hill Air Force Base, Utah, and the University of Dayton Research Institute, Dayton, Ohio, Air Force officials said. Northrop Grumman's major subcontractors on the program are BAE, Receivers, Ball Aerospace and L3 Rantern, Antennas, and Lockheed Martin, Display Processors. The HTE upgrades are part of a massive Air Force B-2 modernization effort which includes new onboard computer processors and improved radar evading technology called the Defensive Management System. The Air Force currently operates 20 B-2 bombers, with the majority of them based at Whiteman AFB in Missouri. The B-2 can reach altitudes of 50,000 feet and carry 40,000 pounds of payload, including both conventional and nuclear weapons. The aircraft, which entered service in the 1980s, has flown missions over Iraq, Libya, and Afghanistan. In fact, given its ability to fly as many as 6,000 nautical miles without need to refuel, the B-2 flew from Missouri all the way to an island off the coast of India called Diego Garcia, before launching bombing missions over Afghanistan. Upon its inception, the B-2 was engineered to go against and defeat Soviet air defenses during the Cold War. The idea was to operate above enemy airspace, conduct attack missions, and then return without the adversary even knowing the aircraft was there. This mission, designed to destroy enemy air defenses, was designed to open up a safety zone or a corridor for other, less stealthy aircraft to conduct attacks.